Hello, how are you? Good morning, good afternoon, good evening to start. We are going for our cup of coffee that you can't miss. We are here to support them and to solve any questions I will do ask. And I hope it is as clear as possible. We continue with the exercises that we leave the last homework class. We leave 3 exercises pending so that you will try to solve. And we comment that in this new episode. Episode 3, we are going to solve them together. I hope you have had any doubts. Have posted in the comments, and I hope they will be resolved at the end of the year anyway. These exercises we continue. We have integral from x to 5a of x. We have discovered that we have a u and we have a du. Right side here we have noted the last episode. Una uy, una du. We comment that this one of u depends on this one of u is the derivative of u. We left in this part in the corner is the formula of the chain rule, which is the one we have been using so far. We were just commenting so quickly, recapitulating. We had discovered that this is the simplest method to solve a comprehensive, but one that we have as a requirement for certain points within them, that we have a du and a u. That du will be the derivative of u, and we have to have it complete, that u that we have the integral can be any function. But as long as in order to use this rule, this formula, we must have the complete du, and if not, we will see later how they are resolved. These exercises we continue with the resolution, and this I'm going to put them in a different color again. The equation we are going to perform to be able to make them easy. We have the integral from x to the 5th, from x perfect. We observe that we have a x at 5th, dx we can observe, and we can take our, if you like the part dx, excellent. This is going to be our u. Let's take our u, and we are going to observe yes or analyze. If we have our full du, this should be because it is the only thing left over of everything we have within the integral would have to be our full du, and in case you do not, let's see if we can. To complete it, we had mentioned that we can only complete the differential of an integral as long as they are numbers. We can add numbers, but we cannot add trigonometric functions, nor can we add any variable. No letter we can add perfect. In this case, we are fine. We have our u and our du. How about putting in this part at the bottom? We rewrite as u our x without taking into account the exponent. This is important. Remember, and our du would be what dx perfect. We make our friendship our mirror to see if we have everything complete. We do our to review. If we have everything complete, we have dx perfect. Well, we have our yes, obviously yes, because that is where our dx excellent, in this case, we have complete differential. This part of here, I'm going to shade it with and lock him up. Is the differential is our du that we had it very well here. Now then, this allows us to be able to use the excellent chain rule, how we resolve, how to substitute. As in the previous episode, I need an exercise that was very similar since we have u and we have du. Our formula is in the corner, which is u to the n plus 1 over n plus 1. The resolution of this exercise, it would be if we have u to the n plus 1 on n plus 1 in order to use the formula. Remember, it is necessary to take complete the u. If you remember, now we take as a nothing more than pure x without taking into account the exponent in this case. In this case of the u in specific, which is in the chain rule, it is necessary to take into account the exponent because it indicates that we need an n. Our n in this part would be equal to what would be equal to 5. Yes, all well, excellent. Then only by substituting in the formula, the part of our u equals x, our n is equal to 5. The formula says to add 1 and divide between that same 5 plus 1. This is going to equal x to the 6th out of 6. And always remember, in the integrals, we add the integration constant, which is c. This would be our solution from our integral from x to 5. Perfect. Now in the second exercise, we leave behind, pending for you to resolve. We have 1 integral of x to the 5th minus 4 dx. Let's turn it back as usual. Rewrite in order to be able to make and not affect the main. We have x to the 5th minus 4, and all that is multiplying by dx. It's like if there were 1 parentheses here, as I just put it to exemplify and clarify that this dx is multiplying both the x to the 5th is at least 4. In this case, what we can take into account, as long as we have a subtraction in this case of x minus 5, as long as we can observe x to the 5th and have a sum or a subtraction of some other number or some other variable. This more and less sign is possible will more or less allow us to separate this integral into quantities in parts. In how many parts? Well, that number of parts will tell us the number of more or less signs we have. In this case, how many signs we have here stand. One number of another, one variable of another, or one variable of a constant. We have this minus. We have only one sign. Let's put a perfect sign here. This sign will indicate that it is possible to allows us with the rules of integrals to separate and convert this integral, which is a turn it into 2 and try to integrate separately. That's why I was telling you at the beginning that this dx affects everything that is in the parentheses. Then both x to the 5th as the minus 4 is affected by dx. Everyone has their own differential, and everyone must have its perfect complete differential, giving continuity to this idea that I've just told you about. We are going to have the first integral, which is going to be x to the 5th per dx. We will have this one less, let's put more to start, the minus 4 integral dx. If it is clear, I will put another color that this x is going to affect first, ALAX, ALA 5a, and then at least 4. But affects both, and I told them that this part of the sign, we have a sign that will allow us to separate, convert into two integrals, the sum of two integrals. Now let's see what happens with the signs, because that minus 4 is going to affect us to that one more that is on the outside. Very well, we continue from this x at the 5th. We can observe we can take more like u is x and see if the differential is complete. We can observe each other. We can observe that x to 5a is like the exercise we had previously resolved. The first one who had stayed on homework, we observed that if we grab as u our x, our du, what should it be? Should be dx, and see if we have it complete. The dx, the differential is dx. We have it? Yes, complete as well. Then it is possible, carry out the chain rule. We can integrate perfectly. How here? We have the formula at the top of this side that says u to the n plus 1 over n plus 1, perfect. Then applying the formula, we would have our u, which is x, our n, which is 5 plus 1, very good. y5, yn is equal to 5. Let's remember, just to review this, 5 is our n. Now continuing with the application of the formula. We have x at 5 minus 1 more. Sorry, between 5 plus 1. This is going to equal x to the 6th out of 6 plus the integration constant. This is going to be our first solution, but first solution why? Because our integral has two parts, has the x to the 5th part and the minus 4 part. Remember here we have two. We have this integral and we have this other integral, perfect. Very well, now how do we solve the minus 4 dx? Check it out. I'm going to pass it this way. We have the sum of the minus 4 dx integral. Very good. Now there is a rule that is important and we had not detected in the integrals. Every number and any sign within an integral is possible. Take it out and leave it alone. The variables within the integral, if possible, they should always be removed from the integral, both a sign and a sign, which is about 1 to 1. As a number, positive. Also in this case we have, if we observe, we have 1 minus 4, we have this minus 4, which is a constant, we can take it out. Yes, and as a procedure, it must be removed. If we have a more on the outside, we have a minus in the inner part, and we take it out. Less for more, it would look very good on us. It would look less on us. Less, we get 0,4 to the integral. And within the integral, we will only have x perfect is important. Not to forget that. All the time and everything becomes simpler to solve as long as we have a number within an integral with its sign. It is possible to, whenever possible, it must be removed and only integrate what subtracts the variables or the dx or the differential, as in this case, perfect, very good. Then we proceed with the solution of the second integral who form a part of the first one. We already have at the top, we already have the first solution. We have left minus 4 that will multiply everything inside the full is minus 4. We have, there is as if there is a parenthesis here, invisible, that will multiply to the integral from x, and you may wonder how I integrate from x. If it seems correct to you, I am going to delete the previous procedure. I will keep the pure result to make room for ourselves and solve the second integral ready. We mentioned that we have the minus 4 and we'll multiply everything inside the integral. Everything we are going to integrate in this case is our turn. Integrate dx. One of the reasoning paths or logic that can be useful to us is the part about knowing the process or the sense of between derivatives and integrals. Or if we remember, I know you all know if we have a derivative, we have a dx. If we integrate it, where we come from here is an integral. We get to x. And what if that x, the derivative would be a dx if we derive that one? X, we reach dx. And if I integrate that of x, we got to x, excellent. Very well, perfect, then that can be useful. Because in this case, it is necessary to integrate directly from x. We can find out from now on, you can assume that this dx2 integral is x. But let's explain a little more. Where does that x come from, or why we can pay close attention? And in this case, we have the minus 4. We are going to leave it here. It will be multiplying everything in the integral. This part of the integral, we have only one dx, but here we have an x to 0. You know that all of it variable, and any number that is at 0 equals 1. Yes, in this case we can put it this other side that x to 0 equals 1, and you can think And what we had here when we had the dx alone, why not? We did not put x at 0. Where was that 1? xy, because x at 0 is 1. Then it is as if we had one of these. Why should I explain them to you? Because here we pay attention and we observe it is possible to make chain rule or not. You comment me if we take here as ux to 0 or x. In this case, we said leaving out the exponent, our du. What would it be? dx. No, we have it complete. We do have it complete. We agree. Recapturing a little bit, we said the u was going to be this part of here without taking into account the exponent and our differential. Our dxo, our du has been what all that is left over is. In this case, we have it complete, and that allows us to make the chain rule, which is the formula simplest we have in the upper right part perfect. Then as we have the complete differential, it is possible to perform and solve it by the chain rule that tells us that we have our u, that the u is x perfect to the n plus 1. How much is our n worth? You tell me how much our n is worth 0, then it would be 0 plus 1 between 0 plus 1, and how much we would have left here, x at 11, that this would equal x, nothing else. And remembering that the constant of integration, the result or solution of the second integral. But if in the beginning we look at the upper left part, if we have this integral, we are asked to integrate this part of here, that at the end of the day, we realize that we can separate it into two integrals by removing the solution individual of the two integrals. In the end, we know the result. We need to gather the results and show only one result. I will proceed to delete again this part of the board to leave you alone. Only the results ready. We note that we have the first result, that was this solution, and we have this other solution. The complete solution of what we were asked to integrate, which was x to the 5th minus 4 of x. The solution, what would be? I'm going to put it in yellow, and it would be x to the 6th between 6, more x, more c. This would be the solution to that we had been asked for in the beginning, or what we had as homework. You may wonder why. Where was it if we had a c here? We had another c because we only have a c. Well, the constants, the integration constant is thus managed. It is the same if we have 2, c3, c minus c squared. Everything ends up being a constant. We do not know what this constant is. Then we can simply assume and leave a single c, which may have any value that in this case and at this time we do not know. Then the correct thing to do is to leave only one c and accommodate the results of the factors that gave us why we put here. How do we know that x to the 6th out of 6 is positive? Yes, because it has no sign. Then it is positive. How we knew we had to add this x good, because in the part in result 2, in solution 2, we had 1x only. That means that we have a more x in this case. For that reason, we were left with the final result, x at the 6th, more x, and at the end, without forgetting the constant of integration in this case, this would be the solution of the second exercise that had been left as a task. In the next episode, we are going to solve the third exercise, and we are going to continue D. I need more homework for you to practice. I hope they have solved these 2/1 exercises, you alone. I hope they have solved the third one as well, and that they have had any doubts as it has been clarified with this resolution that we have done together. Yes, and I invite you to subscribe if you have any comments. Put them at the bottom. If you need any advice on the part, bottom of the video comes information on how we can contact each other. Con todo gusto. Take care of yourselves. See you next time.